Welcome you all to the video lecture on Control Systems Engineering. Today we are going to solve the problem where we are going to find out static error constants and steady state error, where the system is described as it is unity feedback control system and the open loop transfer function G of S is given, and also we have input R of S which is given in the problem. Okay. So we need to find out static error constants. So we have three different static error constant. One is position error constant, velocity error constant and acceleration error constant. So position error constant is denoted by Kp, which is limit s tends to 0 g of s h of s. For Kv we have s into g of s h of s. For Ka we have s square into g of s h of s. So we need to simplify this term, and finally once we have simplified we have to substitute s tends to 0. So let us solve for the position error constant first. So Kp is given by limit s tends to 0 and g of s is given in the problem, which is 10 into s plus 2 divided by s square into s plus 1. And for h of s in the problem they have given that it is unity feedback control system. So unity feedback means we can assume that, so for unity feedback system we can assume that h of s equal to 1. Okay. So using this concept I can just multiply 1 here. Okay, with the g of s I have multiplied 1, which is equal to limit s tends to 0. So let us simplify this term, which is 10s plus 20 divided by s cube plus s square. Okay. So wherever we have s, just substitute s equal to 0. So when you substitute s equal to 0, what happens? Numerator it is 20, denominator it is 0. So any value by 0 it is nothing but infinity. Okay. So Kp is nothing but infinity. So if we have denominator as 0, right, numerator as some constant divided by 0, it is nothing but infinity. So position error constant Kp is equal to infinity, and velocity error constant Kv is given by limit s tends to 0. Additionally here we have one s. Okay. So which is nothing but, and again g of s h of s as usual whatever we have substituted here we can substitute here also, 10 into s plus 2 divided by s square into s plus 1, and h of s value is 1. Okay. So this s and this from s square I can cancel out one s. Okay. So limit s tends to 0. I have numerator 10s plus 20 divided by denominator it is s into s plus 1, that is s square plus s. Okay. So now substitute wherever we have s, just substitute s equal to 0. So this term becomes 0. So numerator I have only 20, denominator again 0 plus 0 it is 0. So 20 by 0 is infinity. Again the velocity error constant it is also Kv equal to 0. For acceleration error constant we have limit s tends to 0 s square into g of s h of s. Again g of s is 10 into s plus 2 divided by s square into s plus 1, and the whole term is multiplied by h of s value 1. So anyway s square get cancelled. So simplify your term. So 10s plus 20 divided by s plus 1. So wherever you have s, just substitute s equal to 0. So this term becomes 0, numerator we have only 20 divided by this term is 0 plus 1. 0 plus 1 is 1. 20 by 1 is 20. So acceleration error constant Ka is nothing but 20. Now we need to determine steady state error. Okay, for that they have given the input as R of s. So for finding out the steady state error we have the formula called ESS, which is equal to limit s tends to 0 s into E of s, where E of s is the error signal in S domain, and E of s is given by, again we have formula called R of s divided by 1 plus G of s into H of s, and R of s is the input S domain of input, that is which is already given in the problem. You can substitute that, and we know already in the problem they have given G of s as well as H of s, we know the value is 1. So first let us simplify and determine what is E of s, then we can substitute in this formula and then we can find out the ESS. Okay. So R of s value is 3 by s minus 2 by s square plus 1 by 3s cube divided by 1 plus G of s value is 10 into s plus 2 divided by s square into s plus 1. Okay, so now simplify your numerator separately and denominator separately. For numerator, the LCM is 3s cube. Okay, so compare this 3s cube with the s. Already s is there, which is not there. That is 3 into s square is not there. Okay, so that 3 into s square multiply with 3. So 9s square. Okay, and then again s square you compare with 3s cube. So which is not there, 3s is not there. So 3s you have to multiply with 2. So it is 6s. Okay, and then plus already 3s cube it is there, no need to multiply anything. Okay, so 3s cube means already 1s is there, which is not there, 3s square. So multiply with the 3s square. 3 into 3s square is 9s square. Compare s square with this, which is not there, 3s is not there. So 2 into 3s is 6s and plus 1. Okay, the whole divided by, now the denominator LCM is s square into s plus 1. Okay, so here 1 I don't have any term, just multiply this term with this. So 1 into any term is that particular term. So s square into s plus 1 plus 10 into s plus 2. Okay, so now the term is 9s square minus 6s plus 1 divided by 3s cube. So this term you can take to the numerator, so reciprocal your term. Okay, so s square into s plus 1 divided by, so you can simplify this term and write s square into s is s cube plus s square into 1 is s square plus 10 into s is 10s, 10 into 2 is 20. Okay, so now this s square and this s cube, s square get cancelled, only 3s is available there. Okay, so here you can cancel out, it will become only s. Okay, so this s square you can cancel out and this will become s now. Okay, so now you have this s and all other terms are there as it is, because we cannot take or simplify this term further. So you can keep this term as it is for your U of s and you can determine what is ESS. Okay, so now we have to apply the ESS formula. So ESS, that is steady state error, is given by limit s tends to 0 s into E of s. So limit s tends to 0 s into E of s value is what, 9s square minus 6s plus 1, okay, into s plus 1 divided by, we have first term 3s and the next term is s cube plus s square plus 10s plus 20. Okay, this is the term what we have obtained previously. So 9s square minus 6s plus 1 into s plus 1. Okay, and then s cube plus s square plus 10s plus 20 into 3s. Okay, so everything I have given. Now s and s get cancelled. So wherever you have s, just substitute s tends to 0. Anyway, this term becomes 0, this term becomes 0. I have 1 in the first term in the numerator. Similarly, this term becomes 0. Again I have 1 alone. Denominator, this term are 0. Only you have 20. Okay. For this term you have only 20 and we have additionally 3 here. Okay. So you don't have any substitution value for this. Just 3 you can use as it is. And then for this term I have 20. So it is 1 by 3 into 20 is 60. So therefore steady state error ESS is given by 1 by 60. Okay. Thank you. Thanks for watching.